Okay, so this is the video for section 8.4 for Algebra 2, which is called compound interest. And the number e. It's a lowercase e that's called an irrational number. We'll talk a little bit more about in a little bit. Today's date is Wednesday, March 24th when you're watching this. Okay, so 8.4, when it talks about compound interest, it starts off with, this is a lot of like how exponential like formulas or exponential models can be used in kind of real life terms where you have, think about finances, especially when you're ready to be, when you're old enough and ready to buy a car or buy a house, or anytime you have even a bank account. A lot of times you're going to have a certain amount of money in a bank account and it'll accrue interest over time. And so this is the interest that we're talking about. So interest is basically just, like we're going to look at specifically something called compound interest. And let me just define that. It is also defined on Michigan Virtual, but just so that you have it in one spot here. Compound interest refers to, it's when interest is given multiple times. So when interest, remember, interest is really just like a certain percentage of money that is given. Sometimes, like when you take a loan, you have to pay interest, so that you're saying, I'm borrowing this money. When I give it back to you, I'm going to give you this much more each time, so that it feels fair. So when interest is computed or given multiple times, it's not based on only the amount that you like initially invest on, but it's about how much money you currently have at that time. But again, it has to deal with how often you're going to be giving interest. So sometimes it depends on the bank account, it depends on the scenario. Sometimes it's a one-time fee where you're going to pay this loan back and you're going to pay this much. It could be a credit card company, it could be so many different things that we can work with. But we can compound interest in different ways, and that's what we're going to kind of walk through right now. So there's a formula that is used to compound interest. It's, again, interest that's paid on an initial investment. The initial investment is called principal. Oops. Initial investment is called principal. So you see that capital P is going to come up in just a minute, where it's like the starting amount that you're going to say, okay, I'm going to give this much money and put it into a bank account to start saving it. And then it can accrue interest over time. So here's the formula, and then I'll label all the parts of it. So the formula that's used whenever we mention the words compounding interest is A equals capital P, and then there's a 1 plus, then there's a fraction here, r divided by n, and then at the top is an exponent, it is n times t. So we should know what each of these variables stand for. A is going to be your final amount. P is what I mentioned earlier, it's the principal, which is your initial investment or starting amount. And then R is the rate. Now, rate will always be expressed as a decimal when we substitute it into this equation. So express as a decimal. And then we have N. This is that word that we talked about, compounding. It just means how often the interest is put into an account. So we'll write number of times compounded. And then finally, T is time. And time can be measured over a period of how many years that you might want. Okay, so in addition to what these variables mean, sometimes some words are used to represent N. So depending on how to represent N, sometimes keywords are used. The most common being monthly. That means if you think of how many months are in a year, N would be 12. Okay, so that's the most common one that's used, but other ones that could be used as well, quarterly is another one. Quarterly means 4 times in the year. If it does not say anything about how often it's being compounded, if it's just kind of like a straight fee, like a rate that's given over a period of time, then sometimes it could be just yearly or annually. And if that's the case, n is just 1. So both of these just disappear if that's the case. And you kind of have like your own new equation like this, where if n was 1, this would be the new equation where you just would need your starting amount, the rate written as a decimal, and time. And then you wouldn't need to worry about compounding in that case. So that's only if n is 1. Other times it can tell you right in the problem, it could say compounded 5 times in the year, and then that n would mean 5 in that case. So it can tell you an actual number. Other ones that you could write here, weekly means n is 52, and daily is n is 365, right? Because that's how many days are in a year. Not counting like leap year and stuff like that. So that's the idea. Let's try some examples out so that hopefully we can be ready for the quiz, which is going to have lots of different examples that are very similar like these. Okay, so let's try example 1, which says write a formula that describes the value of an initial investment of $1,500 growing at an interest rate of 3% compounded monthly. Okay, so we're using the same formula, but we're writing our own with the information given to substitute into this formula. So again, the reason that we're using this formula that we just talked about is because it said the words compounded monthly. So make sure you're reading that carefully, so because we're going to talk about another type of example, and there are 3 questions I think on the quiz that will deal with compounded a different kind, which will say the word continuously, and we'll talk more about that at the end. But whenever it says either compounded monthly or one of these other keywords, or it could even say compounded 6 times a year or 5 times a year, something like that. It means the same thing. So let's go ahead and write our equation. So it'd be A equals, sometimes the equations can be written like this, A of t, like a function, same thing, right? A equals, or A of t, because it's talking about that variable t, because we don't know the time here, so we're going to keep t as that t. This is my principal, P, the 1500. Then we have 1 plus, and then the rate. We do not write 3 for the rate. You have to take this 3% and divide it by 100. So that would be 0.03. So 0.03 divided by n, which is monthly. So 12 is n. And then we would raise it to the 12t, because again, it's nt. So we're just plugging everything into this equation from the formula above. And then when you get to this point, you can stop right there. You don't have to even simplify further. If you were asked to solve this and it said, well, what happens after 4 years? Then yeah, you'd have to put a number in for t, but this is all we had to do on this one. So this is the final answer. This is what you would be selecting as your final answer in Michigan Virtual. And we'll do a couple more like this. Okay, now same idea, but let's see what happens on this next one. So this next one is going to say write a formula that describes, so the beginning part is kind of the same. The value of an initial investment of, let's say, $400. But this time it's going to say that loses, so read it carefully again. This one was growing. This is losing, loses value at a rate of 6% per year compounded 5 times per year. So that means 5 times in the year that interest was put in so that it would equal a total of 6% within that year. We don't know how many years this went on for, so we're going to keep T as time, but we have our initial investment, we have our rate, we have our N, which is how many times it's compounded. But the main difference here is in order to use this formula or this equation that was given, there was a plus here because it was referring to an increase in investment. Now that it's losing value, we are going to change this plus sign to a minus. And that's pretty much it. The rest is very much the same. So actually, I'll leave it there for a second. So you can still see what I'm substituting into. A of t, or you can just say A equals, but the answer choices will all be left as A of t equals. The first value is 400. Then we have 1 minus, so again, that's the main difference here. And then we have, again, 6% have to be written as 0.06 instead of just 6. Again, if you need to actually find the answer, just always do 6 divided by 100 or whatever that percent is divided by 100, or move the decimal point 2 to the left. That's how we get 0.06 and not 0.6. And then we have to always remember to divide by the compounded amount, which in this case is 5. So N is 5 here. And then close that parentheses and raise it to the 5t. So this is, again, the final answer. We don't have to go any further. If we were given a time, like how many years this went on for, we could substitute that in for t, but we don't know that information. All right, let's try another one. Just one quick note about the last 2 examples. Actually, I did check the quiz, and some of them are actually simplifying these a little bit further. So if you don't see this answer exactly like it's written, I can grab a calculator and figure out what is 0.03 over 12. And once you find that, you can add that number to 1. And so that's what we could change this parentheses, or whatever's in the parentheses, to that answer. So it would also be correct if it was written 1500 1.0025 raised to the 12t. So both those are equivalent. It's just 2 different ways of writing it. This you can kind of clearly see I substituted into the formula. Here it's kind of simplified. So again, some of the questions were left like this instead. Same idea with this if you wanted to simplify it. Okay, so the next part, before we get to some more examples, starts talking about E, or this, like we said, this number E. It's an irrational number. So E is an irrational number, kind of like pi, and it has the value of approximately 2.71. I'll write a few of the numbers, but of course they go on for a long time because it's irrational. So 2.71828. I don't know these, but again, these can keep going on. As long as you can know about 2.718, I think that, or even 2.72, something like that, that's close enough to see that the number, that number is going to go on forever. Okay, so this E, the way it came from, it's, well, one way to, another name for it is called the natural base, and we are going to on Friday see more about the natural logarithm, which is going to deal with this E, or this natural base. But we can also use this in some of the similar types of formulas that we've just been working with, where when something is compounded, we saw so far monthly and 5 times here, but if something is compounded, it can be compounded not just a few times in the year, it can be almost like instantaneously or all the time. So in order to use this letter E, what mathematicians found was that the more and more times that they compounded something, it started approaching this letter E. So as you were compounding more and more frequently, from 5 to 12 to 365 to 1,000 to, as many times as you could, that's where it started getting closer and closer to this value. And so let's go ahead and try some compounding problems. The key word here is when you see the words compounded continuously, we're going to have a brand new formula that looks similar to this first one that we had up at the top here, which actually I'm going to go ahead and box, because it's nice to come back to that clearly. Let's now do the same thing here. This new formula will be A equals P, it's a capital P, and then the letter E, which is the natural base, and then raised to the RT. Okay, so the same R and the same T and same P. The only difference is now there's this letter E that we'll have to use a calculator for if you were to try to calculate these. We are just practicing with like writing the formulas, but in the future, if you do need to calculate them, you would grab a calculator and actually do that. All right, so let's go ahead and try out our first example of how we would use these compounded continuously examples. It can be, again, used in any kind of example where you're dealing with money. It could be an example dealing with population. Lots of different things can be compounded continuously. So the similar examples on the quiz are dealing with the credit card, and if you think about interest that's earned on, or how much they charge if you don't pay like your full amount. So we're going to look at a credit card example. Same example could be used, but without the words continuously. So please make sure you read it carefully, any story problem, and if you see the word continuously, that means yes, use this formula. Whereas if you don't see it continuously and you see other words, like here we had 5 times, here we had monthly, or any of these other words, those all indicate that you must use this formula. So the only time we use this formula is when it says continuously. All right, so here's our first example. Let's do, it says, our first example to use with compounded continuously. Example 3, we'll have, so let's say you owe $1,300 on a credit card. Okay, the card charges 15% interest. And then it'll say right after that, usually compounded continuously. That's how we know right away that we need to use this formula, this new one that has an E in it. All right, then we're writing a formula. That describes how much you're going to owe on your card after 2 years. Just to simplify this a little bit, I'm just going to write formula. But if you read through the rest of the problem on the quiz, it'll say write a formula that describes how much you will owe on your card after 2 years, assuming you make no payments and don't incur any additional charges. So that's saying, like, let's say you use that credit card one time to get that $1,300 on it, and then you have this interest that you're trying to pay back. You don't try to purchase more things with that same credit card. You just don't do anything with it. Let's see what the equation would be. Because if you do those things, it gets way more complicated. So to do that, we're using this equation again. A of t, again, is the same idea as a. We're just writing it as a function. 1,300 is my principal right here. And then E is the letter we use to represent that we're doing it continuously, right? These keywords. And then R is always written as a percent or as a decimal. So you want to take 15 and divide by 100, which is 0.15. That's part of the exponent. And the T we don't know, so we're going to keep it T. This is the final answer. You can't go any further from here. Just key things to be careful of. I know one of the answers on Michigan Virtual will write this as 15T. Don't forget that you have to convert it to a decimal. Other common mistakes are to forget to use the E formula and use like the other one. So you don't want to use the 1 plus 0.151 and get like 0.615. That would be incorrect. Same with here. Don't try to add 1 to the exponent. There's no exponent that has a 1 there. It's just R times T. All right, we'll finish up with one last example like this, just so that you can see something similar on the quiz, and then we'll be all set. So the last example, so this is example number 4. And example 4, we'll do kind of the same idea, but again, we'll see one example of what happens when you're losing that money. So here's the formula from the last page. Oops. P, E, and then RT are up at the top there as an exponent. Both those are exponents. And remember, you can only use this when it says the words compounded continuously. Okay, so let's do example 4. Let's say it says write a formula that describes the value of an initial investment let's say this time it's $3,000 that loses value. We did one of these earlier on the front page. I think it was example 2. But again, look at that word carefully. Loses value at a rate of 8% per year, compounded continuously. So as you read through these story problems, again, you're looking for keywords. Make sure you look out for the word compounded and see what comes after it. If there's the word continuously after it, you know you're using this formula right here. If it doesn't say the word continuously after it, then you know that you have to use then the first formula that we looked at, which had the A equals P times 1 plus R over N over NT. So we have that information. P is my initial amount, which is 3,000, the initial investment. E is that same irrational letter we have to use. R would be written as 0.08 because that all, oops, I wrote this wrong. It's 8% per year, not $8. So it's written as 8 anytime you have a percentage given to you, you want to write it as a decimal. And then T, we don't know, but we're going to keep it time. So final answer would be A of T equals 3,000 e to the 0.08 t, but here's the catch. It was losing value. So anytime something is losing value, just like we did on the previous one, you're going to make your rate a negative. So it's like negative 0.08 t is the final answer there. So this negative goes right in front of, it still has an exponent. It's not up at the front or anything. It's just that since the rate is, since you're losing value at that rate, that's what you're going to make negative. All right, and that's the final answer. So there are a total of 6 questions. We went over 4 of them because the other 2 are very similar to the ones we just did. Please try out that quiz if you still need some more practice. Remember, there's a quizzes that you can try out. You can also try the practice problems within Michigan Virtual's lesson, and obviously look over the lesson. There's a lot of detail there that we didn't go through in detail. All right, if you do have questions, please send them to me, or you can put them in the Google form as well.